Section 9.3 is the same thing as the previous section, with the only difference being that now we're working with a problem that has two quantitative samples instead of two categorical samples. To start, let's go through all the different ways we can find standard deviations for the different tests we learn. Remember that when we're dealing with categorical tests, we're working with percentages. We don't have numerical data, so we can't find a mean and a standard deviation. An example would be going out to 1,000 people, asking if they're planning to re-elect a certain politician, and in the end, we're left with a single proportion. We'd use that proportion to find the standard deviation with the equation radical PQ over N. Once we add in a second sample, we just have two individual fractions of their own PQ over N. That's for a confidence interval. If we were working with a hypothesis test, we would take each of these and pool our proportions to come up with one single p-hat for both populations combined. Compare that to quantitative tests. Here we have numerical data. We can get a mean and a standard deviation. Standard deviation is what we use to find the standard deviation of the sampling distribution, sigma over radical n, or more likely S over radical n. Now when we add in a second sample, okay, we have our first sample here. We're going to add in our second sample by adding the variances of both of these samples. Okay, so we square the top, square the bottom. We have S squared over N for each individual fraction, add them together, square root them. So in this section, we're dealing with two quantitative samples. We're going to be finding standard deviation by that last equation on the previous slide. For our first example, we have farm sizes from 8 farms in Indiana County, Pennsylvania. We have an average and a standard deviation for those 8 farms. And then we have the same information for 10 farms in Greene County. Average, standard deviation. Does this provide evidence that the average size of farms in the two counties is different? We're going to start by defining the parameters. When we write the parameters, we're not writing P equals anymore because we're not dealing with proportions, and instead we're dealing with means. So mu sub I is the true mean size of farms in Indiana County, mu sub G, the true mean size of farms in Greene County. Just like the last section, the null hypothesis is that these two things are always equal to each other. It's never anything other than an equal sign for that null hypothesis. And the alternative is based on the wording. For this problem, it's asking, are these two average farm size different? Okay, we can rewrite them with minus signs in between them. This is how you'll typically see it in the book. So to find the standard deviation for this problem, where we're combining the variability of these two individual samples, we're going to take our sample data here, and in particular, we're interested in the standard deviation of both these samples. Okay, I have an S here because these standard deviations are just based on the farms that we sampled. Standard deviation is going to be combining these two variances. So normally it would be S over radical N for each of these samples. Square the top, square the bottom, S1 squared over N, or SI squared over N, plus SG squared over N. Okay, we plug everything in, and we simplify this to 13.96. So I have all our key information summarized at the top here. The one thing that I want to call attention to is the alpha level over here, 10%. That's from the original text of the problem. Now we want to find the critical value for that alpha level, and we're working with a t-distribution because we don't know the standard deviations of the whole population. We only know the standard deviations based on these 8 farms in Indiana County and 10 farms in Greene County. If we knew the standard deviation of the population, we would be dealing with sigma instead of S. So in the past, when we've done t-distribution problems, we always started off by finding degrees of freedom. The issue is here now we have 2 samples. Okay? One was of size 8, the other was of size 10. If these 2 sample sizes are different, we're always going to default to the smaller sample size. So we're going to use 8 to find the degrees of freedom, and it's still 1 less than that sample size. So we're on 7. Okay, we're on this line here. It's a 2-tailed test because of our alternative hypothesis, and the alpha level is 10%. So we end up with 1.895. From here, we want to find the test statistic. Let me clear out some of this marker here. So test statistic is based on our null hypothesis, which says there's no difference in between these two, and the standard deviation that we found on the previous slide. Okay. In actuality, there's a difference of 8 in between these two averages that we found. Would that be usual or unusual based on that mean and that standard deviation? Okay, so I have Indiana County first, Greene County second. It doesn't matter if you have them flipped. The 8 would just be over here, which we're going to have to find anyway because it's a two-tailed test. So we plug those in. We have -8 over the standard deviation of 13.96. That gives us our test statistic, -0.573. Remember, anytime we evaluate a hypothesis test, it's always based on the null hypothesis being true, which is why we have a 0 in the center of our curve here. Now we want to use that test statistic to find the p-value. So we have a test statistic of -0.573, and the question is, where does it go on this line with 7 degrees of freedom? If we look at all the numbers on this line, we can see it's smaller than even the smallest number on this line of 1.415. So 0.573 would go out here to the left of all the numbers on this line. And since it's to the left of all these, we know that the p-value is even further to the left than this number here. We can see these numbers are increasing as we move to the left. So our p-value is greater than 20%. So now we have a p-value, we have a critical value, we have a test statistic. Let's actually come up with our conclusion. We're going to do it both ways. First, we'll do it using the critical value. So up top here, we have the critical value that we found on the previous slide. We got 1.895. It's positive and negative because our alternative hypothesis is not equal to. So if we end up with a test statistic that's more extreme than this critical value, we would reject the null hypothesis. And for this problem, we got -0.573, which would be about here, not in the shaded region. So at this point, we're able to make our decision. We're going to fail to reject the null hypothesis since the test statistic falls outside that shaded region. Or we could say fail to reject the null hypothesis since the p-value, which we know is greater than 20%, is greater than the significance level of 10%. We write a conclusion. It's always about this alternative hypothesis. And in this case, we fail to reject, which means we have insufficient evidence. So there's insufficient evidence to suggest that the mean acreage of farms in Indiana County is different than the mean acreage of farms in Greene County. That was the hypothesis test. Let's do the same problem again with a confidence interval. The wording in the text of the problem changes because now it's asking us to estimate the difference in the true mean acreages of farms in both these counties. We're going to use a 95% confidence interval. Defining the parameters, same thing, and important information listed across the bottom here. Next step, find the standard deviation. Now recall from the last section when we were dealing with proportion problems that had 2 samples, we had to change the way we found our standard deviation, whether we were working on a hypothesis test or a confidence interval. That's not the case with mean problems when we have quantitative data. We find the standard deviation the same way regardless of what type of problem we're doing. So it's s squared over n for the first sample, add the same thing for the second sample, square root that sum. We get that same 13.96. Part D, find the critical value. Again, we have 2 samples up here. We're going to pick the smaller one if they're not the same and use that to find degrees of freedom. So we're on 7 degrees of freedom. Confidence interval is 95%. And we get our critical t-score of 2.365. Part E, find the margin of error. This is just that t-score times the standard deviation. 2.365 times 13.96 gives us a margin of error of 33.02. At this point, we have everything we need to write the actual interval. And when we write the interval, we start with the point estimate, that point estimate being how different are these 2 samples. So there's 8 in between these 2. It doesn't matter which one we put first. Okay, it'll change the sign of that 8. If we put this one first, it would be a -8. I'm going to put the G one first, the Greene County one first, because I like dealing with positive numbers. So 199 minus 191 plus minus that margin of error of 33.02. Now, if we switched the order of these, this would become negative and it would change how we write our interpretation in the next section. But for the last step in part F, add and subtract 33.02 to 8 and we get our interval, -25 to +41. Part G, we want to interpret this. we are 95% confident that the true mean acreage of farms in Greene County is between 25.02 acres smaller and 41.02 acres larger than the true mean acreage of farms in Indiana County. The way you write this is important, and it's based on whichever order you had these up here. So I had Greene County first. That's why Greene County comes first in this interpretation. And it's saying it's between this much smaller and this much larger on average. Okay, we're talking about the means. Okay, Indiana comes second in our sentence. Based on these results, can we conclude there's a difference in the average farm size in the two counties? No, we cannot, and the reason is that 0 is in between these two numbers. Remember, this whole interval is telling us what do we think the difference in the average farm sizes actually is, and we think it's somewhere between 25 acres smaller in Greene County all the way up to 41 acres larger. Since that interval includes 0, it's possible that there's no difference in the average farm size across these two counties.